Continuing to work with powers. So we're going to talk about the power of a product property, our third property dealing with powers. So to find the power of a product, find the power of each factor and multiply. So if I have a product inside my parentheses here, so I'm multiplying factors together, and I have an exponent on the outside of those parentheses, I'm going to find the power of each factor. So I can do 3 to the 4th power, and I can do 5 to the 4th power. So this kind of feels to me like a distributive property. I'm kind of taking this exponent and using it on each of the factors in there. It's not distributive property. Distributive property is very specific, but it kind of feels like that to me. I'm kind of taking the 4 and using it on all the factors inside my parentheses here. So let's take this and simplify each of these expressions. I have 5y, and that whole expression is to the 4th power. So I'm going to apply my 4th power to the base of 5, the factor of 5, so I have 5 to the 4th power. I'm going to apply my exponent to this base of y, so I have y to the 4th power, and 5 to the 4th power is 625. So I end up with 625y to the 4th power. Let's look at this one that only has variables. So I have ab to the 5th power. Now this is a times b. When I have two things together like that, it's multiplication. So this is a times b. I'm going to kind of explode this here and have you see what it looks like, the long version. So really this is telling me to do ab times ab times ab times ab times ab. There's 5 of them there. So if I think about what this means, if it's all multiplication, so I can kind of mix them up so that the like terms are together, I've got 1, 2, 3, 4, 5 a's. So that is a multiplied by itself 5 times, so that's a to the 5th power. And I've got 5 b's there, so that is b to the 5th power. Again, if I go back to my property here, I could have done a to the 5th power and b to the 5th power, but this is what it means. This is what's really happening here. And c, I have 5/10 mn to the 2nd power, so my 5/10 is to the 2nd power, m is to the 2nd power, and n is to the 2nd power. So again, I'm applying that 2nd power, that exponent, to each of the factors inside my parentheses. All right, next a couple of word problems. Let's kind of use all of these properties that we've been working on as far as word problems. There are 5 to the 12th power blades of grass in each acre of land, and a section of land has 5 to the 4th power acres of land. How many blades of grass does the land have? Leave your answer in exponent form. So I have 5 to the 4th acres, that's how many acres I have, and each acre has 5 to the 12th blades of grass on them. So I know that each acre has this many blades of grass on it, so I'm going to multiply this times how many acres I have. This is in 1 acre. I'm going to multiply it by however many acres there are. So I'm going to multiply these two together, 5 to the 12th times 5 to the 4th, and I know that if I'm finding the product of powers, I'm going to keep the base, I'm going to keep that a 5, and I'm going to add the exponents. So I have 12 plus 4 gives me 16. It's set to leave our answer as an exponent, so we have 5 to the 16th blades of grass. I should have a label on that. All right, our next one, Jack buys a carton that has dimensions a to the 5th power by 2b to the 3rd power by b to the 2nd power. So I've got a length, a width, and a height here. What is the volume of the carton? So first I need to start, this is an FSSU. I'm going to start with my formula, volume equals length times width times height. I'm going to substitute in each of the dimensions that they gave me, and then I'm going to multiply. So my 2, we always put, if I have a constant, a number, we put that out in front. My a to the 5th, there are no other bases that are the same, so a to the 5th just stays a to the 5th. And I have b to the 3rd times b to the 2nd. I'm going to keep that base of b and add my exponents to get b to the 5th. So those are the dimensions for the volume of my carton.